Experimental setup of photoelectric effect. Dear students, here this experimental setup, if you understand, then we can observe here the earlier scientist who has contributed for the photoelectric effect from Hertz to who has produced electromagnetic waves initially from Hertz to Leonard, Henry, okay, followed by that up to Einstein we will get to know. First, in photoelectric effect, we should understand what is this experimental effect. Then, whatever laws and consequences, everything we will get to know here. So, how we will get to know this? In the photoelectric effect, first of all, how the experiment is set up takes place. That is the most important thing we need to know here. In this experimental setup, first we have a evacuated quartz tube, evacuated glass tube we have, and it's supposed to have small window with the quartz transparent surface. And in this evacuated glass tube, we have one cathode metallic surface, means cathode electrode, I can say, and the other side anode electrode. These two electrodes are connected in external circuit with some resistance and with the external source, the battery and key. And the anode is connected through the microammeter. Why we are using microammeter? Ammeter is a purpose of using measuring the current, but microammeter I have connected. This is a major purpose is very small amount of current is passing, so that must be measured here. Now, here you can see that from cathode to anode while it is passing, we have parallelly voltmeter is connected. And here the resistance is connected with the rheostat wave. Means it shows the variable resistance. Now we can measure voltage and current also. And the further circuit is when you are on, then usually cathode and anode. Before it was simply a metal plates. When you have turn on the switch, then these two are acting with the opposite potentials. Since I named it as a cathode and this is anode, cathode means it is having negative charge, anode means it is having the positive charge. Okay. Now, here you can see that why I said this is anode and this is a cathode. You will understand now. First, I have taken a source of light, that is UV light. When ultraviolet light, I have taken a source and I'm incidenting the light on the cathode. You are finding two electrons are released gradually. The released electrons are moving towards the anode. Since anode positive terminal, it attracts the electrons. At cathode, it releases the electrons. Okay, because of UV light which is incidenting on the metallic surface, therefore metallic surface is started emitting the electrons. Okay, the UV light is nothing but it is a light, it constituent photon particles. Okay, but I'm not talking about the photon particle is now itself, it's light I am concerning. Now you can see that the photoelectrons, nothing but the electrons which are emitted from cathode is moving towards anode. So since it is a glass, it transmits any visible and infrared lights, but not UV light. So glass transmits only visible and infrared lights, but not UV light here. But since I am using the quartz glass or quartz window, it allows the UV light. When a light of suitable frequency falls When a light of suitable frequency falls on the metallic cathode, then the photoelectrons are emitted. These photoelectrons are attracted towards the anode, which is the positive potential or positive terminal, and hence the photoelectric current develops that we can notice by the deflection in the ammeter. Okay, means whenever it reaches, then it became a complete closed circuit. There is a deflection in the ammeter, we can find out. From this experimental setup, we have effects. That effects we are going to discuss in the next video. Thank you.